Hello everyone. Today my topic of discussion continues with group theory. I have already discussed about what is a group and I have discussed in length the addition modulo 6. See, is it 6 plus 6 is a group. I have proved that this is a group under this plus 6 operation. Detailed explanation has been given on this in my lecture 1. Now this is my lecture 2. This is my lecture 2 on group theory. See, this is group theory. On group theory. See, let me, though I have discussed briefly about what is a group and everything, let me make you understand more about the subject by giving some simple examples. See, let E be equal to 1, 2, 3 dot all positive numbers. Let me take all positive natural numbers and I will define an operation ordinary plus. This ordinary plus is an operation in this. You will find that for all a comma b belonging to E, a plus b belongs to E. This is closure property. This is closure property is satisfied. And under addition, a plus b plus c will be equal to a plus b plus c for all a, b, c belonging to E. Associative property. So when these two properties are satisfied, therefore E plus is called a semigroup. Is called a semigroup. So, if there is a non-empty set and you define an operation, understand that this plus need not, I need not mention it as plus. It is a star operation. See, you can call this as E star operation where the star is plus. And it can be combination of operations can also be the star. Star means not necessarily one operation. Can be combination of many operations also. And here in this particular case, I have taken this plus. This is number 1. So this is a semigroup. I have defined what is a semigroup. A semigroup is a group, a non-empty set is said to be a semigroup under a certain operation star. If you can write this as also, see, you can write this as A star B belongs to E and A star B star C is equal to A star B star C. So this way also you can write. So if these two conditions are satisfied, then E will be called as a semigroup. Let, see, now I take this. Let n be equal to 0, 1, 2, 0. All positive numbers and 0 and this set of all natural numbers. You find that under this star operation, let star operation be equal to your plus. Let your star operation be equal to your plus. Then we find A plus B belongs to N for all A comma B belongs to N. Any two elements you take, you do the addition, you see that it will gain an element of N. And So this is closure property is satisfied, and A plus B plus C is equal to A plus B plus C for all A, B, C belonging to N. So this is N. So that means this associative property. So this is closure property is satisfied, associative property is satisfied, and additionally this 0 is here, 0 plus A is equal to 0, A plus 0, A plus 0 is equal to A for all A belonging to N. Now you see that this is nothing but your identity element, additive identity. So what is an identity element? An identity element is 1. An identity element is 1 which when operated with any element in the set must result the same element. That we must get the same element. For example, you see that 0 is the identity element here. Therefore, 0 plus any element will be equal to A, and therefore this identity element has been established. So three properties are satisfied. One is your closure property, then is your associative property, and your identity element, existence of identity element. Therefore, N is called a monoid. It is called a monoid. It is called a monoid. Therefore, we have seen now what is a semigroup, what is a monoid. Semigroup is a set which contains elements and the operation is defined as star. Then you see that under that star it is closure property and associative properties are satisfied. Additionally, if we can establish the existence of identity element, then it becomes a monoid. Now we will go further. One more step we will go. So you see that. Now let me take one more example like this. See, let I'll take this, let Z be equal to minus infinity dot 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 minus 3 minus 2 minus 1 0 1 2 3 dot dot all integers. See, Z consists of all integers. Now in this set I define the operation star. The star is nothing but your ordinary plus. So your star is nothing but your ordinary plus. So under this, you see that you will find the following results. That is, see, A plus B belongs to Z for all A comma B belonging to Z. So this is, you take any two elements. You add them, you will find that it is again an element of Z. Therefore, closure property is satisfied. Closure property satisfied. And now this is your number 1. And A plus B plus C is equal to A plus B plus C for all A, B, C belonging to Z. This is associative property. So this A plus B plus C is equal to A plus B plus C, and this shows that the associative property is satisfied. Okay, then this one, then you see that there is this element is 0 is there. So 0 is the identity element. 0 plus A is equal to A plus 0, which is equal to A for all A belonging to is that any element you take, you see that when it is added with 0, it is itself. Therefore, 0 is identity element. So 0 is identity element. This is the identity element. I'll write it here. An element. Now, you will find that the fourth property and new property I am introducing. for any element on the, say you leave off this 0, you take any element here, you will get a corresponding element on the left hand side, and which if the two elements are added, you get it as 0. That means you take any a here, you will find the corresponding minus a here, add this a plus of minus a is equal to 0. That means for every element a here, there exists a corresponding inverse. We call it as an inverse element, that is if a is an element, if a belongs to z, a dash belongs to z such that a plus a dash is equal to the identity element, then a is said to be the inverse of a dash, or a dash is said to be inverse of a. Can you understand? Now if it is, now here we can very obviously see that for every positive number there is a negative number. For every negative number there is a positive number, such that a plus, you call it as, you will find this minus a is present, and this minus a plus a, if you add, it will be equal to 0. So identity element. Therefore, for every a there exists a inverse element, and say existence of inverse. Existence of, I'll write it here. Existence of inverse. So we are able to establish the existence of inverse element. Therefore, 4 properties are satisfied. This is, see, closure property, associative property, identity element is there, and inverse element existence of. Therefore, Z plus is a group. So if all these 4 properties are satisfied for the elements in the set S, we give the set in the set, then such a set will be called as a group. And moreover, you observe one more property, that a plus b is equal to b plus a for all a b belonging to Z. You add a plus b is equal to b plus a. So this is commutative property. So this implies commutative property is satisfied. Therefore, Z plus is a commutative group or abelian group. I'll write it here. Therefore, here, because of this, since now Z plus is a group, and since commutative Z plus is a commutative group or abelian group. So this is all about to have a very good knowledge on group. These are the things that are required in order to have a better idea about a group. Now, let me prove that this multiplication modulo 4 is not a group. Multiplication 4 is not a group. See, multiplication modulo 4 is not a group. See, that is Z4 into 4. This is called your this thing. where Z4 is equal to 0, 1, 2, 3. You just go through the first lecture on addition modulo 6. This is multiplication modulo 4. And here you see that how we get these elements are. Now I will prepare the table. See here what we do is, you take these are the only elements. Let me prepare the table for this. Say it is 4, 1, 2, 3. It is 0, 1, 2, 3. This is 0 plus 0 into anything is 0. 0 into anything is 0. So this is 0. This is 0. This is 0. 1 into anything is itself. That is 0. 1 into 1 is 1. 1 into 2 is 2. 1 into 3 is 3. 2 into 0 is again 0. 2 into 1 is 2. 2 into 2 is 4. I told you 2 into 2 is 4. But modulo 4 means it can be written as 1 into 4 plus 0. So the remainder is 0. Therefore it falls in the class 0. And 2 into 3 is 6. 6 can be written as 1 into 4 plus 2. Therefore it falls in the class 2. So this is class 2. 3 into 0 is 0. Then 3 into 1 is 3. 3 into 2 is 6. That is 4 plus 2, 6. So this is, you are getting it as 2. 3 into 3, 9. So 2 4s are 8 plus 1, 9. So this is 1. So this is the table that we get. So this is the table. Now, you will find that any two elements you take any two elements in Z4, you will find that A multiplication modulo 4 will be equal to your C, and C belongs to Z4. So you see that this is true. So that closure property is satisfied. And A into B into C will be equal to A into multiplication modulo 4 into B multiplication modulo 4 C. So this is also true for all A, B, C belonging to Z4. You see that, for example, you see that 2 into 3, you see 2 into 1 into 3, 2 into 1, see 2 into 1 will be equal to 2 into 3. So 2 into 3 will be equal to 6, that is equal to 2. And 2 into 1 into 3 is equal to 2 into 1 into 3 is 3. So this is 2 into 3, 6, so it is equal to 2. So these two are equal. So they are equal. That means this closure associative property is satisfied. And you can find that 1 into anything. See? So associative property is the closure property satisfied. And this associative property is satisfied. And you will find that number 3, see 1 belongs to Z4 is identity element. Identity element. Because 1 into anything is, you see, 1 into 0, 0, 1 into 1 is 1, 1 into 2 is 2, 1 into, so this is identity element. Therefore, you are able to get. Now 1, see, this is identity. See, 1, see, closure property, associative property, and identity element present. Therefore, Z4X4 is a monoid. But you will find that fourth property, namely, the inverse must be present. That means you go to this 1. Here it is 1. So the inverse of 1 is right. The inverse of 3 is 3. Inverse of 3 is here. But you don't find the inverse of 0 here. Inverse of 2 is not here. See, inverse for 2 and 1 are not there. See, inverse, say, write it here, inverse of either 2, because 2 means you must get 1 is the identity element, therefore you must get, see here it is 1, so the inverse of 1 is 1, inverse of 3 is 3, but inverse, there is no 1 here, that means the inverses of 1, inverses of 0 and 2 are not there, and the fourth property is not satisfied. Hence, see, there is no, and therefore Z4X4 is not a group but a monoid. So this is how we deal with the problems. I will do more problems in the coming days. Thank you.